Hi everyone again. My name is Sucharita. I'm a Director of Engineering at Quicken. And Quicken is a personal finance software maker based out of US. So as Shruti said, I'm passionate about microservices. I'm happy to share what I know today, and then a little bit focus on testing strategies as well. And any question you have as we go through this presentation, keep typing it away in chat window. We'll get to them at the end of the conversation. Shruti will help moderate that part of the conversation. Thanks. With that, we'll get started. Okay, so the agenda for today's topic is basically first, I'll walk you through how software architecture has evolved over the years. So hopefully it shouldn't take too long, but this helps provide some foundation to why microservices came about, and then briefly touch upon how microservices architecture looks like. Pretty much any company that's adopting microservices will have some version of this blueprint. So it's a very good idea for all of you to take away this blueprint. One thing, if I say that you should take away would be this blueprint. And then, of course, testing strategies that all of you are part of testing community. So I plan to touch upon a few strategies that you can work on and then adapt it to your work. And of course, at the end, we'll leave plenty of time for Q&A. Okay, so how has software architecture evolved over the years? So I've been fortunate enough go through this journey myself. So back in late 1990s to early 2000s, a lot of things were starting to change in technology landscape. Every business was just going online. Everybody has a website, and thin clients are everywhere. And Java was kind of becoming a language of choice for people to build web applications. And J2EE was a predominantly a platform of choice to build applications, right, backend applications. And some patterns emerged as part of J2EE. Three-tier architecture became popular as an architecture pattern to build enterprise applications. The pattern itself would look like this. Pretty much every application built during those times would have a business logic tier and database tier, UI tier, and then you have your thin client running in browser. And then you use HTTP to go into UI tier, and then UI tier goes to business logic over wire using RMI, and then of course business logic talks to database tier using JDBC. And then set of technologies that you use at every layer are kind of listed there. I'm not going to go through the details, but you just kind of get an idea. One thing I want you to focus on is the business logic tier, where we were using EJBs. If you come from that part of the world, EJBs were popular at the time. And then mid 2000s, J2E kind of started to crumble because of performance issues of EJBs, and application servers that support EJBs are expensive. WebSphere, WebLogic, if you worked on those. And then because of all these reasons, EJBs kind of went out of favor. Spring Platform emerged as a strong open source alternative. So I've kind of come from J2E world, and then used JGBs and then went into Spring Platform, right? And that's an open source. And then with Spring, what happened is 3 tiers became 2 tiers, right? I'll show you a little bit 2-tier pattern that most of the applications in early 2000s, UI tier and business logic tier kind of merged. They all became one part of JVM, and then you have browser and of course the JDBC going to databases. So you have this big gigantic layer that's beginning to form in majority of the applications. So another variation of this, when web mobile apps becoming popular, essentially mobile apps, the entire UI tier kind of went into mobile app, and then business logic kind of remains the same. Right? These are the technologies. And if you, throughout this presentation, I like to kind of build on a story. So I'm taking an example of blogging application. Let's say you are a part of a team building a blogging application. I just chose this because all of you can connect to it. I can easily explain without going into too much of domain complexity. So think of blogging application where you can sign up users, users can create, update, get blogs, and they can create communities. They can share blogs with others, whether it's users or communities. And let's say the team kind of is formed and started building this application, right? So it would look something very similar to what I'm showing. So you'll have a bunch of services, user service, blog service, community service, and you have a database tier. And of course, UI tier will have its own set of classes. And one thing to note is all these services we are talking about are just the logical components. They are just simply Java classes built in the same JVM, running in the same JVM. So one single process. Okay. And then product manager says, okay, let's add some more features. Let's add comments to blogs. Let's add tags. And I want to be able to search blogs. And I want to users to follow blogs. So a whole bunch of functionality gets exposed. And at that time, early 2000s, business to business integrations were happening, and also SOAP-based web services were becoming popular. And they exposed these functionality as an API, but it is predates REST API, so SOAP-based web services. And now your application has SOAP-based web services as well as REST APIs, right? Because it's evolving your application. So now it will look like this. A whole bunch of new classes get added to business logic tier. It keeps bulging, keeps getting complex. They all get intertwined. Lot of dependencies get added within the same JVM, right? It's all happening in the same process, and process is becoming bigger, and code base is getting bigger as well. And so all these applications which kind of survived and kept increasing in the complexity, reality was that many applications become big monoliths, right? While code bases started become bigger, process got innovated. So this is around the time where Agile got introduced. Scrum process was becoming popular, and people wanted to move faster in small teams. And team structure has also changed during this time, where teams are geographically distributed. You could have teams working in various geographies on the same code base, right? And business model, all businesses, as I said, SaaS based models, and expectations from a SaaS model is that features go to production very quickly. So product managers are trying to keep up with the competition, so they say features have to be rolled out very quickly so we can learn, iterate, and execute. So the expectations kind of evolved from teams, from actually even customers expect different things and at a different pace. While all this is happening, code base kind of remained the same, architecture remained the same, but it was no longer sustainable, right? The pace at which team is asked to operate, it is just not sustainable. So hence, why I'm saying all this, all these are motivations to do something different. Fundamentally, how code is built. Just to tell you, the microservices is not about a new programming language or packages. It can be Python. You can write stuff in C++, Java, doesn't matter, but it's more of an architecture pattern people can follow using any technology that they are familiar with. So kind of expectations it came with. To solve all the challenges that we have seen in the past, from dev team's perspective, it should be easy to enhance and easy to upgrade underlying software packages. Let's say you have written this big monolith, and if you want to upgrade Java version, or if you want to upgrade Hibernate, or you want to upgrade any library that you use, or a Spring, it used to be a major effort, right? You need a big team to coordinate and then do all at once. So dev teams wanted an easy way to try out and these upgradations without needing a lot of coordination. Another motivation is expectation actually from microservices is to experiment new technologies. So we have technologies are evolving, NoSQL, you want to quickly try out, maybe for this feature, MongoDB is better than, MySQL. But it used to be very difficult to do these kind of experimentations if everybody's working on the same code base. So it also they also want work to happen in parallel without tripping each other. So there are days where we would spend 2-3 days just to fix build issues, because there's a team of 100 people working on the same code base. So these are all the challenges dev teams have in the past with monolith. So they want microservices to solve for those. And every new member that would join the dev team, this humongous database, it's very easy to get lost in the details. Of course, QA teams, they want an easy way to test and automate, run regression and very quickly, and then push it to production. And operations team, they want to be able to deploy, easy to scale, easy to diagnose, and troubleshoot and operate. So these are all various expectations different teams have with microservices. So with microservices, I'll touch upon few design principles, if you will, that help you. Again, I want to lay a foundation, some of the challenges also with microservices, right? And also how people do it. So here I'm saying, these are some principles dev teams use to deploy these microservices. You split business logic into separate services. You all know that. And while doing it, each service should own its data. You don't want, again, all services go and talk to the same database instance. Then it defeats the purpose. Make sure that they are very independent. So each one will have its own database. They can evolve schema of that database independently. And at the end of the day, even though they're all split into multiple services, there is always a dependency. You can never have a microservices architecture and say, service one never talks to service two. That cannot happen. But when there is a need, make sure that they're talking to each other using a well-known interface, like APIs, right? Well-documented APIs. And now let's say if we as a team decided to build this blogging application using microservices pattern, it will look like this, right? Business logic tier is now split into 3 different services: blog service, user service, follow service. Each one of them will have its own database, and possibly each one of them is owned and supported and tested by different teams. Now we can have independently operating teams that can evolve these services independently. So follow service could possibly use a NoSQL, right, without worrying about or coordinating with user service team. So that's the kind of power of microservices, right? And then client talks to all these services through APIs, REST APIs. So that's how the blogging app would look like. But wait, now is everything okay? Are we kind of done building microservices? Now, actually, it has now become a highly distributed application. Earlier, user service, blog service, and follow service, they're all running in one single JVM. Now they are running in a different JVMs. Hence, they're all running in separate processes. They all became a distributed application. So with the potentially, over years, you could run into situation of, hundreds of small services. We currently have in Quicken, for example, we are close to now 100 small services and hundreds of databases, right? And then it can easily turn into a nightmare unless care is taken from the get-go, right? And actually, it is not an exaggeration to say microservices architecture is 10 times harder. But it has these big advantages of moving quickly as teams. But of course, everything comes with a price. So microservices architecture is complex. So it's not hunky-dory. And because they're all highly distributed with distributed applications, you have to assume all these things. You have to assume that things can fail anytime. And any service can stop and start anytime. And assume that, when they come back up, they could come back on a different host. In a virtualized environments, they could come on a different VM, different IP address, etc. And then assume there will be over-the-wire dependencies. So it's no longer in process, but it's actually on the wire. And now on the client side, client has to deal with so many services, right? Instead of working with one big monolith, now it has to deal with many services, and so on. So if you don't care for all these and work on them on the get-go, put those foundational elements, it can turn into a nightmare. So some more design principles, how do we solve for all these, all these issues? Yes, we have all these issues. Now, how does one go about solving them? Briefly, I'll continue the design principles you can use. One challenge that we talked about is everything can fail, which means we have to make sure services are highly available. So that means, you run multiple instances of each service and make each service stateless so that all instances are equal. An API call can go to any instance and get required response. And another principle, every service, we said the challenge is service can stop and start anytime, and they can start on a different host. So which means when client is making a call, it should be able to discover where the service is running. So we have this pattern where you can implement a service registry, and that every service can register. Okay, here I am, blog service, I'm coming up, I'm coming on port 1234, and this is my IP address. So that's how they register, and then clients and other services, that's how they discover. So basically, you don't hard code any IP address or port. It is all available in the registry. And at the end of the day, even though microservices are fairly independent, but there will be some dependencies. First is to try avoid calling other services synchronously. Definitely don't call them, and make eventual consistency as part of your design strategy, and think about eventual consistency over consistency. And what I mean by eventual consistency, let's say from browser, you are creating a blog, and one way to do it is, let's say you're building functionality where you want to make blogs available on a search, and you can say blog service will send blog to a search service, and which will make it available through search. Right, it goes to Solr, and then the results will come. This is one way to do it, but this is a hard synchronous dependency. The other way to do it is, if you're okay with eventual consistency, you can actually make blog service push an event, and then let search service pick it up whenever it can, and then push the results to Solr search engine. Again, it depends on a case by case basis. In this case, it's okay if there is a small delay in making your blog available for searching. So in that case, it's a very, very good use case to try this approach, asynchronous calling. A simple guideline, you always make sure, where you want to make it a synchronous dependency versus asynchronous dependency. So blog applications with all these design principles and some more becomes like this. This is an important diagram. Please take a note of this. So you have all these blog service, user service running multiple instances, and then you put load balancer in the front, and then load balancer allows you to discover. There is also a discover server that helps. It's a service registry, config server where all the configurations are stored centrally, and then you put a gateway in the front so that client doesn't have to know blog service is running on this port, this IP. All the API calls from client goes through a gateway, and all API calls go through one single entity. And then some of the things, I'm just highlighting technologies that we have used at Kickan. We use each box there, it's a cluster. So we deploy everything on AWS. So we use AWS ECS cluster manager. You probably heard about Kubernetes. That's another open source alternative people use. A discovery server, we use Spring Discovery Server. And then a load balancer has a Spring Discovery client that talks to Discovery Server to find a particular service. And then common event stream, we use Kinesis, but other popular choice is Kafka and RabbitMQ. And Zool, Netflix Zool as a gateway. And then we also have ID generator, we use Snowflake and Spring Config, and we use Spring Boot for building every single service. So this kind of, I call it as a microservices blueprint, and some variation of it is what is used every company. So I hope you're able to follow this. All right. So now, if you can zoom in into microservice, what does microservice contain inside of it? If you zoom in the code, so you have three layers predominantly. You have REST layer, service layer, and DB layer. So REST layer is what actually allows service to expose APIs. And then a Tomcat container is what makes it run on a particular port and then wait for incoming API calls. So just remember this as we go through next slides. Okay, now this main topic that you are probably maybe more interested in, testing strategies for microservices. Actually, if you think about it, testing strategies are not very different from what you follow if you're coming from monolith, but I'll just add a flavor of microservice for these strategies. And first, I want to take you through different stages testing takes place in any company, any team. First, you start with unit testing, predominantly done by developers. It all depends on each dev team, how they do it, whether they do testing at a class level or group of class level or entire service level. But I'm not going to talk too much about the unit testing. And then service and component level testing. So each service will have a team in the microservices land. You'll have a dev team, you'll have a QA team. The QA team will focus on component level testing, and of course subsystem level testing and client acceptance. You are probably more familiar with me than all these stages. Performance testing is another aspect. In the interest of time, I'm going to cover mainly the middle three: service, subsystem, and client acceptance. Performance testing actually needs its own dedicated session. So why do we have this many stages? You all know, sooner we find issues, better we are. And most importantly, we should avoid issues leaking to production. So any issue found during unit testing impacts only dev team. Service testing impacts only one QA member maybe, and the dev. Subsystem, if you let issues go through subsystem level testing, more teams are involved, more impact. So your goal is to find issues early on. Okay, so now let's look at what do I mean by service level testing. So again, I put up this microservice slide here. So I just added few more things. So let's say, for example, we take blog service. You have all these layers of code inside, and ultimately it exposes REST APIs. What I've added in this diagram is other dependencies. So that's the flavor of microservice architecture. So blog service will have dependencies on other services, and other services may have dependency on blog service as well. So if you go from left to right, so activity service, it may be calling API on blog service. Right? In the second one, user service, blog service may be calling user service to get user details, or it could be receiving events from another service called comment service. So these are all basically the design principles I talked about. If you have an asynchronous dependency, you may actually be receiving events from other services. So these are all happening because of microservices. Earlier, in a monolith, all of them will be inside this big box. So very less choice, the less chance that the calls will fail. Within JVM, you're making one class to another class. Rarely that you'll see issues cropping up. But the moment they are on the network, you're making network calls to go to other services, you have to assume certain things and then test for it. So you kind of got an idea, right? What kind of dependencies one service could have on other services. So now coming back to keep that diagram in mind, let's talk about what is expected from service level testing. So goal one, this is normal, right? You're testing the functionality exposed to clients. First level of testing is API contract. If you are familiar with REST API testing, this is very familiar. I'm sure you know all this. And just to walk you through what is expected as part of API contract testing. You want to be able to test a request and response payloads. And API contract means all these bullet points. It means HTTP headers that may be passed as part of the request. it may be the error response that you get from the API. And error response itself has two things: HTTP overall status code, right? You get 500, 400, 4xx, 5xx error codes. And there may be other custom error codes defined by your particular service owner. And then a lot of APIs have this behavior of pagination. If the API returns you multiple elements, multiple resources, there is a notion of pagination, right? You want to get page 1, page 2, page 3, like that, and then sorting. So these are some common metadata that API may be exposing. So when we say API contract, it means all these things. So moving on, as I said, this is a flavor of API contract testing is nothing new. It is true in monolith, it's true in microservices. What is different in microservices is internal APIs. So as I said, blog service may expose an API to activity service. So that's called an internal API. So as a tester, as a QA engineer, you should always ask the dev, are there any internal APIs that I should be testing? Because you are kind of certifying the service. And for this, again, it's a normal REST APIs. The same guidelines apply, API contract testing. And asynchronous event testing, as I showed you, you could be receiving events from comment service. So make sure you ask that question. Are there any events that this service handles as part of its functionality? So incoming events you should include in your service level testing. What do you test? Basically, you simulate those events and see if they are being handled properly. And some guideline, usually what we have done, we use APIs exposed by the event stream. For example, in our case, Kinesis has APIs, or SQS, which is a queuing system. They all expose APIs that you can use to simulate pushing events to your service. And I'm sure if it's a RabbitMQ or Kafka, you can do something similar. But main point here is, you always test internal APIs as well as incoming events, both in your service level testing. And another important aspect of service level testing is uncovering backwards compatibility issues. Very, very, very important. You don't want to push another version of the service that breaks existing clients running in production. So let's say you have blog service version 1 running, and then you made a whole bunch of changes, you certified it, and then you pushed it. Then in production, existing mobile client having issues. So absolutely, you want to avoid that. So what do I mean by backwards compatibility? So these are breaking changes, we call it. We talked about API contract. All these sort of changes that happen to API contract can be called as a breaking change. So things to look for is, are there any mandatory attributes added to the request? So mandatory attributes break from service version 1, version 2. Version 2 introduced mandatory attributes. It is going to break the existing client in the production. Did we remove any existing attributes? So that's a big no, right? So you want to uncover these issues as early as in service level testing. So have they changed data type? It is supposed to be a numeric, and then did they change it to a string, or did they change it to an array? So these sort of things have to be uncovered. Has the error code changed? Maybe 400 became 404 HTTP status code. These are all the sorts of things you want to look for. Response payload, has the behavior changed? Any attribute which is supposed to carry certain value or certain understanding of that value, has they changed the logic behind it? So all these are kind of breaking changes. If somebody added a new attribute, that's not a breaking change. Or if somebody added an optional query parameter to the API, that's not a breaking change. So it's important to know what is breaking and look for those in your service level testing. Just an example, let's say you are at QA doing testing for blog service. There is an API called getBlogs/blogs, and then response is giving list of resources, and another API getBlogs, and it says include deleted, and it returns list of blogs. So what is considered a breaking change? Let's say this is what you deployed, and then next version you're about to deploy, you're certifying it, you're testing it, and they accidentally or unknowingly removed author attribute. And then you deploy to a production, of course, a mobile client or web app using that attribute will fail. Will either crash or will have an unexpected user experience problems. And then again, get blogs. If this query parameter, let's say, is added in the version 2 and they made it mandatory, this API is going to fail if you deploy it to production. Likewise, if somebody were to change status code from 400 to 404 or some other, client may not actually have not handled it properly. So these are all things you pay attention and ask and uncover and ask these questions to developer. So that's about backwards compatibility. That's another goal of service level testing. Right. Moving on again. Another goal is, as I said, in microservices land, you have to assume dependencies. What we talked about is in the past, incoming API calls. I'm talking about outgoing API calls. Let's say blog service is making a call to user service. That's an outgoing API call. So you want to make sure that those are tested as well. So kinds of things that you have to test, again, like any other service API, you assume successful response, error response coming from user service. And again, this is a flavor of microservice. You have to assume that these services could fail because all these API calls are happening over the wire. And the errors could range from 500 errors because other service is busy sending timeouts. It could be some other internal server error for that service, could be authentication authorization errors. And then how do I test these external dependencies? Some pointers. Usually your aim in service level testing is to be independent. You don't want to wait for other teams to help you configure those components. Avoid dependencies on other services. So one way to do it is you use mocks. And for databases, again, if you want to avoid going to any component on the wire, even database dependency you want to avoid, rather than mocking everything database layer, use an in-memory database like a HSQL. Let's say your actual database in production is MySQL, very compatible. You can use in-memory database. Your code should work exactly identical. And other services, if you have a dependency on, let's say, user service, try to use mocks. And make sure that all these are configurable through property file without needing to change code base. So this is one conversation you would want to have with developers. Make this service in a way that I can inject mocks so that I can test all the external dependencies independently. So based on all of these, you can see that service level test are very, very important. That stage is very crucial in microservices land. And they're also good candidates to automate because if you mock everything, it can run independently with no configuration needed on all other services. And you can easily integrate with the build process like Jenkins server and get the results without worrying about a whole bunch of dependencies. So it's a very good candidate to automate and integrate. It's kind of called continuous integration. And some technology choices that we follow, we use Postman for manual API testing and Fitness to build automated tests and integrate with the build system. And we use service mocks using Makito. And then Spring dependency injection allows you to inject these mocks into the code. And then do talk to your dev teams about giving you a Spring profile that you can simply specify and then run that service using that profile, QA profile, integration profile, prod. And if you were to run this service in QA profile, expectation is that it comes up with mocks. And as I said, HSQL as a good choice for in-memory database. So I'm just going to pause a bit. Okay, now Subsystem testing, what do I mean by subsystem testing? You probably also call it integration testing. The idea here is to test a group of collaborating services together to test certain features end to end. Usually it consists of multiple services which are connected over the wire as opposed to in process. This is again a flavor of microservices. They are all going to be connected over the wire. And you don't typically want to use mocks. You're basically testing the whole functionality exposed together. So external dependencies, don't use mocks. It's actually real services get used. An example, again, going back to our blog service, let's say blog service in the middle, it is exposing create blogs, get blogs, and then it is dependent on comment service and user service. Your test case, for example, you sample test scenario, create a blog, add comments, and then moment you call get blog, you expect blog to return with top 5 comments, which would have come from comment service. So you are basically testing the whole set of collaborating services. In this case, you may want to give slight delay between, let's say, add comments and get blog, because your actually comments are going to comment service. Comment service has to push all those events through event stream, go to blog service. So your understanding of the architecture plays a major role in subsystem testing. So keep the blueprint I've explained in mind, and ask those questions. How do I test this whole functionality when you're having conversations with dev teams? So this is what I mean by subsystem testing. In this case, you don't use marks for comment service or user service. You use actual services that are deployed in integration environment. Yeah, so goals of subsystem testing is mainly client-facing features end-to-end, and test whether services are all wired properly. Are the services are talking to each other? Is the event stream configured properly? Is the user service configured properly so that it's actually working, and then blog service is able to communicate? So you're basically testing the communication aspect of it. And of course, you also test positive and negative. And if you have done a very good job in service level testing, you should not find too many issues in this, right? Because you would have mocked all these responses and tested it already. So that's the whole idea here. Just a small note about client acceptance testing. It depends on the size of the company whether they have this or not, but it's a good last minute verification. So goal is to uncover last minute issues missed by earlier stages, and typically you coordinate with client testing teams, whether it's a web app team or mobile team. Anytime let's say you're pushing out a new version of blog service to production, before that in integration environment or any pre-prod environment, you deploy it and have client testing teams to quickly run some sanity. Not the entire functionality, but frequently used functionality of that service. So other alternatives, it depends on how big the team is. If a services team has bandwidth, you may want to build a client acceptance test suite for each client that uses your service, and automate it or run it yourself so that you have less dependency on them. But of course, you have to keep up to date with the test suite, depending on all the features that client may be using. So just a quick note about client acceptance testing there. Yeah, I think that's about it. And then good references. They have a lot of articles and practical examples. Now, how you do all this mocking, what technologies to use, and pros and cons. So do take a look at these websites. And I also highly recommend this book by Chris Richardson. If you can just buy it, and there is chapters there on testing as well, in addition to microservices in general. So with that, yeah, so I think we are at the end of the session. Hope you found it useful, and I'm open to any questions you may have. Shruti, over to you.
Yeah, audience, whatever the questions you have, you can just post it on the question panel towards your right. Yeah, I'll forward it to Sucharita. Sucharita will give a minute for audience to push their questions.
Yeah, sure.
Okay, there's one question. How the microservice will affect the manual testing?
Manual testing. So
Yeah.
as I said, in service level testing, you typically want to do manual testing to begin with, all the APIs to understand. But ultimately, you want to actually translate that into your automated tests. So the role of a manual testing, I don't think it has a big change from monolith to microservices. Ultimately, you're testing your APIs. So whatever you have followed for manual testing applies here. Let's say you put up your Postman and then you run your API test. Unless is there any specific question or concern in manual testing?
Okay, yeah. So we have one more question. What testing utility tools are available for creating the mocks?
Yeah, so mocks, there is a two ways to do it. One, you run a mock server. There are a lot of generators available. It takes your API and builds a mock service, which you can literally have it return 5xx, 4xx, any error code you want. But still then you'll have an external service running that you are hitting. It's a mock server. Other way to do it in process is ultimately inside the microservice, you have business logic tier that I showed. You can inject mocks into that layer, but developers need to make that possible. So they have to give a configuration where you can say, I want to inject this mock, right? They have to provision it, and then using Mockito. Mockito is the library that people use, and we have used that as well. Using that, you can inject a mock, and then you have to code for it. So a little bit of coding is involved, how you write your mock. Those are the two ways. Either you run it as a mock server, or you inject mock business logic classes into the same process.
Yeah, so next we have one more question. How the microservice will affect the UI automation?
UI automation, I don't see anything affected by microservices, because you're testing UI. For example, you have a browser-based application. Underneath it is going through gateway, all the API calls. But if you're testing UI, I don't see any change between monolith. Microservices has no role to play here. It's all happening behind the scenes. You continue to use whatever you're familiar with for UI automation, and then underneath it's all API calls at the end of the day.
Yeah. So we have one more question. What is the difference between the microservices and SOA?
Yeah, good question. So service-oriented architecture, um, at the on the onset, it's conceptually they're all same. They're all actually service-oriented architecture dates back into, I think, if I remember, late 1990s or early 2000s. It's a way to expose your monolith application as a service, right? At the time, all applications were monolith. How do I expose this functionality to another business that I want to integrate with? So let's say you're exposing your business functionality as set of APIs, and then you have a totally different businesses that want to integrate. I give you an example. Let's say there is a company that provides a credit score, right? And then I'm a company that want to give this functionality to my users. I want to integrate with those external services and then get a credit score and give that functionality. So other company will expose their functionality as a service, as an API. So that's how service-oriented architecture came about. That's a way to integrate different businesses. B2B integrations made possible because of service-oriented architecture. But it's more of an umbrella term. So now you can, if you apply to microservices, just a mini services that are being exposed. Conceptually, it's the same concept, but the term kind of went out of favor recently with microservices. So web services, if you remember SOAP-based web services, that's when SOA became popular, and every business was exposing web services. I don't know if that helps, but conceptually they're both same.
Okay, yeah. So we got a reply for that stating that was an awesome answer. Okay, yeah. Thank you, Sucharita, for explaining the concept, complex concepts of microservices in an easy to understand way. So I'm sure that we all are now better equipped to understand the concept of testing in the composite landscape. So if anyone have any questions, please feel free to reach out to us. We will forward that to Sucharita and we'll get them answered. So thank you again, Sucharita, for breaking down the subject into very simple terms. And thank you, audience, for participating in the webinar. Thank you all.